Hi everyone, I'm going to go over a few problems from the atoms and bonds assignment that was on the chemistry lecture. We're going to go through just 3 problems that should hopefully help you get through all the others. So let's look at number 8. Number 8 I did in class with at least one class. I'm not sure if I did it with everyone. So let's go over how to solve these problems by analyzing the question. So calcium has 20 protons. Complete the table below based on what you know about ions. So what we're doing, we are turning a calcium atom into a calcium ion, which gives it different properties, and it means it has different numbers of electrons. So I already told you that a calcium atom has 20 protons. So 20 protons has a calcium atom, and calcium always has 20 protons, just as carbon always has 6, sodium always has 11, hydrogen always has 1. That's what makes it its element. So the number of protons never changes if you have the same element. So that's also going to be 20. Now with electrons, it's a little bit different because in an atom, the electrons equal the protons. So in the pure atom, we have 20 protons and 20 electrons, which gives it a neutral charge. It's not positively charged, it's not negatively charged, because protons are positive, as we know. Electrons are negative, and if we add those up, think about a number line. Look over here on the left. If we have 0, then we have +1, let's say +2, +3, and if we go down, -1, -2, -3. If you have a -1, I'm going to do this in a different color. If you have a -1 and you add 1, you end up with 0. If you have a +1 and you take away 1, you end up with 0. So we have 20 positives and 20 negatives, and that gives us a neutral charge. Now, in order to figure out the number of outer shell electrons, we need to look at the periodic table, which is the next slide. So let's take a look here where calcium is. So calcium is over in group 2. This is group 2, and here is calcium, and this is from your textbook. Calcium is 20, number 20, its atomic number, and in group 2. So we went over this in class, but group 1 has 1 electron in its outer shell. Group 2 has 2 electrons in its outer shell. And we skip over the transitions, we don't care about those. And we're going to go over to where boron is. This is group 13. In some places we call them 3 as well, but group 13 has 3 electrons. It's 4 electrons, 5 electrons, 6 electrons, 7 electrons, and whatever this is full. So calcium, just like beryllium here, and magnesium, and strontium, and barium, and radium, they all have 2 electrons in their outer shell. So that's how we know about that one. From the periodic table, we learned that calcium has 2 outer shell electrons. So in order to figure out what happens with a calcium ion, let's draw an image. So I'm going to use green to indicate the nucleus. And we know that the nucleus contains 20 protons and however many neutrons. We don't really care right now. And around it we have electrons, and we have to count up to 20. We have 1, 2 in its lower shell. In the next shell we have 3, 4, 5, 6, 7, 8, 9, 10 total, with 8 in this next shell because that's how many it can hold. And then we're going to get up to 18 with 8 more from this shell. 1, 2, 3, 4, 5, 6, 7, 8. And in its last shell, I'm going to do it in purple. We have 2, because that's what we said. And I'm going to put them over here. Now this shell, if you recall, I don't think I made you write it down, but in the textbook it says that this shell can hold 18 electrons. It's got 2 electrons in this 18 total shell that are whizzing way far away from this nucleus here. And calcium would really like to not have any, because these electrons, if they were to go away, it could have a full outer shell of this one here, this last blue shell. So that's what's going to happen, actually, is that calcium is usually going to donate these 2 electrons to another atom to create an ion. So if these 2 electrons go away somewhere, we've now lost 2 electrons. So our 20 is going to become 18. 18 electrons. So let's erase this outer shell, because that is no longer there. And here we have the calcium ion. Now we have to figure out what its charge is, because it was a neutral charge when we had 20 and 20, but now we have 20 and 18. We have 20 plus charges and 18 negative charges. 20 minus 18 is going to be 2, and it's positive 2. So calcium's charge is now 2 plus or plus 2. I'm not picky, because those electrons are no longer part of calcium. So its charge, because it has an imbalance of electrons, is 2 plus or plus 2. Now 2 doesn't tell me anything. I need the positive or the negative. It's plus 2 because we have a positive 2 charge. It's a little different from math, but please put the plus in there. And if we take a look at its outer shell to answer this final box here, we see that we have 1, 2, 3, 4, 5, 6, 7, 8 outer shell electrons. Not 0, because it still has an outer shell. Even though that last one went away, we still have an outer one, and it has 8 in its outer shell. So I hope that helps explain how ionization works. I'll write that word down. Ionization is the process of something getting or receiving or giving away electrons that will change its overall charge. Let's look now at question 11. Draw an ionic bond between magnesium and oxygen. Label the atoms and indicate electron movement and charges. To figure this out, we're going to need to take a look first at the periodic table. Here's the periodic table from your book, of course, and we're going to be looking at magnesium and oxygen. Magnesium is right here above calcium, which is the one we were looking at a moment ago, and oxygen is up at the top right there. So let's figure out how many electrons they have in their outer shell. Magnesium has 1, 2, just like calcium did in the previous question, and oxygen has 3, 4, 5, 6 in its outer shell. Oxygen's atomic number is 8, and magnesium's is 12. Let's see what we can do with that information. So with that information in mind, magnesium, we said, has 12 protons and 12 electrons, and oxygen has 8 protons and 8 electrons. So let's draw what those look like. Here we have magnesium, And its first shell, of course, has 2 electrons. The next shell has 8. We're going to fill it up to get to 10. And we have 2 more electrons. So I'm just going to stick them out here to this side. So this shell can hold a total of 8. So we're going to mark out 6 empty spaces, and there's our magnesium atom. If we draw oxygen, oxygen has 8 electrons. So we'll start with 1, 2, 3, 4, 5, 6, 7, and 8 with 2 empty spaces in the outer shell, which can hold a total of 8. So what we see here is both of these atoms have incomplete outer shells. Magnesium has 2 extra and oxygen is lacking 2. So what's going to happen is that when these two come into close contact, these 2 electrons will be transferred over to oxygen. And by doing so, the outer shell for the magnesium is going to go away, and oxygen will have a full outer shell. So let's draw what that looks like. Try that one again. Not a very good circle. Better. All right. And then oxygen. Again, I'm going to put a little X just because it looks like a circle or a ring or an O. Now they're both going to have full outer shells. And these last 2 electrons are from magnesium. Those are the ones that were transferred over. Now let's think about their charges. Charges is really important in ionic bonds. Magnesium lost 2 electrons, so it was left with 10. And oxygen gained 2 electrons. Excuse me, so now it has a total of 10. So we have to figure out their charges. So if we have 12 positive charges, if we look at magnesium, 12 positive charges and 10 negative charges, we're going to have an overall charge of +2 or 2 plus here because we lost two electrons. And the oxygen gained 2 electrons. So it's going to have an overall 2 minus charge. And this here forms an ionic bond because the charges are opposite, opposites attract, and they are bonded together. The last problem I'll be working for this assignment is number 13. Draw covalent bonding between 2 oxygen atoms. Indicate electron movement and make sure electron shells are full. So let's figure out, we just saw what oxygen was from the last question. Oxygen has 8 protons and 8 electrons. So if 2 oxygen atoms are going to be bonded to each other, let's see what that looks like. Again, I'm going to do an X next to the oxygen. Otherwise, it just looks like a circle. 3, 4, 5, 6, 7, 8. And 2 empty spaces. And let's do a second oxygen in a different color. Let's do that in orange. 1, 2, 3, 4, 5, 6, 7, and 8 electrons. So both of these oxygens now have 2 empty spaces, which means they can each make 2 covalent bonds. Ooh, that's bad handwriting. You get the idea though. So let's try it first with just 1 covalent bond over on the right. So if we're going to have oxygen on the left, let's say it's going to donate this one and this is going to donate this one. These are going to come together to form a covalent bond. Let's see what happens. So we started with 8 electrons each, remember. So we have to end with 8 electrons each with a total of 16 electrons. So if we draw what it would look like if we just made 1 covalent bond. So we moved this particular electron to form a covalent bond. I'm going to turn that red. The other oxygen had the same situation where it donated 1 electron. And we color that electron red. Oh, that was bad. Let's count up all our electrons. So we started with 16 on each. So on the oxygen on the left, we have 1, 2, 3, 4, 5, 6, 7, 8. And on the right, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's great. So let's count our empty spaces though. In the outer valence shell, we're sharing 1 pair, 1 covalent bond. And if we count up, including that covalent bond with the left oxygen, the blue one, we have 1, 2, 3, 4, 5, 6, 7. It does not have a full valence shell. We still have 1 empty space because we had 2 to begin with, and we need to fill up both of those. So each of these oxygens has the same situation and is each going to have to donate a second covalent bond, second electron to make a covalent bond. All right, so now we have 2 covalent bonds, and let's take a look at the unpaired electrons. So if each one's going to donate 2 electrons to make 2 covalent bonds, they have 4 unpaired electrons each. 1, 2, 3, 4. And this one has 4 as well. 1, 2, 3, 4. Now if we count up our electrons in the outer shell, let's see how many we have for the left oxygen in blue, including the bonds. 1, 2, 3, 4, 5, 6, 7, 8. Excellent. How about the other one, the orange one? 1, 2, 3, 4, 5, 6, 7, 8. They both have full outer shells, and that is a correct double covalent bond between 2 oxygen atoms.